Welcome to this explainer. Okay, if you've ever struggled with getting a perfectly precise response from an AI model, you know exactly how frustrating it can be, right? Today, we're demystifying a concept called the max mutual information, or MMI method. Basically, it's a systematic, highly scientific way to optimize your AI prompts. So let's dive right in. Think about it. How do you actually know if you're using the best possible AI prompt? Honestly, most of us just kind of throw spaghetti at the wall. We tweak a word here, add an exclamation point there, and just cross our fingers hoping the AI suddenly gets what we want. It's a completely universal frustration, and let's be real, it wastes a ton of time.
So here's our roadmap for today. First, we'll look at the prompting guessing game. Then we'll answer, what is MMI? After that, we'll cover the MMI advantage, walk through the four-step process, and finally, look at MMI in action.
All right, starting with part one, the prompting guessing game. You know, prompt engineering often feels like endless trial and error, but it absolutely doesn't have to be. Guessing what the AI wants based on pure human intuition, that's incredibly inefficient. We often just assume we know how a model parses language, but that assumption leads us straight down a rabbit hole of endless revisions. But here's the good news. We don't have to guess anymore. We actually have a data-backed, rigorous method that lets the math do the heavy lifting for us. It gives us total certainty where we used to just rely on blind luck.
Which brings us to section 2. What exactly is MMI?
Okay, let's dive into this. Max Mutual Information, or MMI for short, is a method used to choose the optimal prompt template by maximizing the mutual information score between the template and the AI output. Now think of this like a definitive compatibility score for your prompts. When you brainstorm a bunch of different ways to ask the AI a question, MMI is the vehicle that mathematically determines which one of those variations perfectly aligns with the model to get you the exact result you need. It essentially scores how well your input maps to the desired output.
To really grasp this, we need to understand the underlying concept, mutual information, or MI. Straight out of information theory, this basically quantifies how much information two variables share. In the AI world, it measures how much your specific prompt reveals about the model's actual output. Let's break that down into plain English. If knowing your exact prompt makes the AI's final answer highly predictable, well, those two things share high mutual information. They're deeply connected.
The absolutely crucial point to remember here is that a prompt with a high MI score is highly likely to produce accurate responses. The core intuition behind this is just incredibly powerful. See, a high score practically guarantees your prompt is going to yield a correct answer. And get this, you don't even need to know what the correct answer is in advance. The math simply proves that the prompt structure and the desired format of the output are entirely in sync with each other. It completely removes the ambiguity.
Moving on to section 3, the MMI advantage.
So why use this? There are massive practical advantages to adopting this system over manual testing. First off, no labeled data is needed. This is huge. It means you don't have to build these massive spreadsheets of correct answers just to evaluate the prompt. Second, no model access is required. You don't need to tweak the underlying weights or parameters of the AI itself. Third, it works seamlessly with your own custom brainstorm templates. You dictate the starting point. And finally, it's incredibly efficient and computationally scalable. This is going to save you a tremendous amount of manual tuning time when you're looking to deploy prompts at scale.
All right, section 4, the four-step process.
This brilliantly illustrates how the whole workflow breaks down into 4 clear, easy-to-follow stages. Step 1, generate templates. You can write variations yourself or even have an AI brainstorm a list of options for you. Step 2, run sample inputs. You feed a few test runs into the model just to make sure the prompts are actually generating reasonable outputs. Step 3, calculate MI scores. You run each template through the algorithm to get a concrete number based on those outputs. And step 4, choose the highest score. It's that simple. By keeping this logical workflow in mind, you can apply MMI to pretty much any AI task you encounter.
And finally, section 5, MMI in action. Let's set the stage and look at step 1 in the real world. Say we want to find a country's capital. We might brainstorm a few template variations like these. We've got a direct question, what is the capital of country? A fill-in-the-blank style, the capital of country is, an imperative, tell me the capital of country, and maybe a more conversational one. Country has a capital city called. Now, we want the model to just give us the name of the capital city. But which of these phrasing options will give us the most efficient, accurate answer without any extra fluff? Well, let's test them out. So, for our first test run in step 2, we use the prompt, what is the capital of France? The AI outputs, the capital of France is Paris. Obviously, this works. The data is accurate, but notice how verbose it is. It essentially repeats the entire question right back to us. Now, if you're building an app processing thousands of these queries, that extra text is a real problem. You need to know mathematically which prompt gets straight to the core data without wasting expensive tokens or compute time on, conversational pleasantries.
Moving right along to step 3, we calculate the MI score for that first prompt, which establishes our baseline at 0.85. Now, it's a solid score. It means the prompt and the output do share a good amount of mutual information, and the model clearly understands what we're asking for. But remember, the whole goal of this process is absolute optimization. So let's see if another template from our list can beat that baseline.
Now, what's really interesting here is how a slight tweak changes absolutely everything. We use our second template, the capital of France is, acting purely as a fill-in-the-blank prompt. The AI output simply says, Paris. Boom. It perfectly understood the assignment and delivered an incredibly concise answer, stripping away all that conversational fluff we saw in the first example. It quite literally didn't waste a single syllable.
And the math totally backs up this efficiency. The calculated MI score for this second fill-in-the-blank prompt jumps up to 0.92. This proves mathematically that the second template is much more closely aligned with producing the exact, highly specific data point we're looking for. The mutual information is higher because the prompt restricts the model's response path directly to the core answer.
Putting them side by side delivers the clear proof. Prompt 1 scored at 0.85, and Prompt 2 scored 0.92. Clearly, Prompt 2 wins the MMI test. It answers the prompt as efficiently as possible, eliminating any unnecessary tokens or filler words. So we've scientifically proven our best template without having to guess, and without having to scroll through hundreds of sample outputs just to figure it out ourselves.
Let's see how this builds and translates into real-world scaling. Once that optimal template is locked in, our winner, the capital of country is, we can scale it to any new input without a second thought. For example, we plug in Shad, and the prompt becomes the capital of Shad is. The AI outputs a flawless, concise, and Gemini. The system operates beautifully, efficiently, and predictably every single time, all because we're using the most mathematically sound prompt available.
As our source material summarizes perfectly, MMI is a simple and efficient approach to selecting the most effective prompt template for a given task. The true value proposition here is the total elimination of guesswork, a real game changer. You no longer have to rely on a gut feeling or spend hours manually testing variations or just cross your fingers hoping the AI will behave. You simply let the objective metrics reveal exactly what the AI responds best to.
So how will you use MMI to optimize your own AI prompt library today? I strongly challenge you to stop guessing and start measuring. Apply this scientific 4-step framework to your everyday workflows and just watch your accuracy and efficiency skyrocket. Thank you for joining me for this explainer, and hey, happy prompting!